Hi everyone, my name is Aman Sharma and this particular webinar is about high availability. There are a lot of terms in high availability in RAC which usually make people very confused, and this webinar is basically going to be clearing those particular confusions. So about me, I have been using Oracle for over a decade. I'm an Oracle RAC. I have co-authored 2 books, and I serve on the board of the Oracle user group as vice president, and also I'm the lead of the North India chapter and founder of the North India chapter, regional chapter of AIOUG. Like I said, there are a lot of technical keywords which are basically there in terms of high availability when it comes to high availability, like TAF, FAN, FCF, application continuity, transaction guard, and so forth. And this presentation is, or this webinar is basically going to be clearing these particular terms for you. So to start with, we basically talk about the Oracle RAC. The Oracle RAC is basically a software-based clustering solution where Oracle's cluster software, or now called the grid infrastructure software, basically maintains the clustering aspect across multiple nodes. There are going to be minimally 2 nodes, and the number of nodes actually can vary depending upon the version. From 12c onwards, the number is 2000, and these nodes are basically going to connect to a shared storage, which is actually going to be presented to each of the node as like it is an exclusive shared storage available to each one of them. And this part is going to be done by the cluster file system, which is going to be deployed on the top of this particular shared storage. Now the database is going to be accessed by the applications, and that's where the requirement of the high availability or load balancing actually is required, because it is the applications which are basically going to require to actually work seamlessly without really having any trouble, or without really actually having to worry about what is actually happening on the database tier side. So this is basically what is going to be the requirement actually, that when we have an application, it should be really able to work without really facing any issues or much issues actually, and it should be able to do the work as much transparently from the particular error which might have come on the database side. So what are the possible solutions which Oracle Clusterware or Oracle RAC actually provides? Well, the first thing is load balancing. You can actually have the workload balanced across different set of nodes of different sessions in terms of the Oracle RAC. There are different options available for it. It could be a client-side load balancing, it could be a server-side load balancing, it could be a runtime load balancing, and of course there are many things actually which are going to be required to make this load balanced environment actually work. The most others, or the second most common or important thing about RAC is high availability. And high availability in RAC is basically limited in terms of 2 kinds of crashes which are possible. One is a node crash and one is an instance crash. And the terms that we discussed, FAN, TAF, and so forth, they are basically going to be applicable to this particular aspect. Of course, RAC can also be used in some parts of performance or to improve the performance, and that's basically going to be in terms of the features which RAC provides, for example, cache fusion and the faster network and so forth, and of course to a certain extent load balancing as well. But obviously it is not really going to be a mandatory thing that just because you have RAC, obviously you're going to be having better performance for sure. Now, very quick thing about load balancing, it is definitely going to be making the workload of your sessions spread across multiple nodes in terms of the Oracle RAC. So like I said, there are many different ways actually to do that, but since this particular webinar is not about load balancing, so we're going to stop over here. The failover is basically going to be one of the things which are actually very important, and is very usual to happen in terms of a clustering environment. So basically what exactly is a failover? The failover basically is that the client or the session is actually going to be getting an error message because its session is actually disconnected, and because its session is actually disconnected, now it actually has to reconnect. And the reconnection, how it is actually going to be happened in the case of RAC, that is basically going to be the part which is actually going to be about the RAC or the failover actually is going to be doing for us. Like I said, there are different ways to do that: TAF, fan, and so forth. And we're going to see actually in this particular session how how these particular things are actually going to work. The most important thing in terms of RAC is the Oracle services, and basically Oracle services, usually it is termed as that Oracle services actually are going to be the name of databases, and to a large extent that can be true also, because when you make a database by DBCA, definitely in terms of the Oracle database environment, the service name is equal to the database name. But that's not usually the case, or that's not always the case actually in terms of especially in terms of the Oracle RAC environments, because in terms of the Oracle RAC, or even in the case of single instance, it is possible that we can create a service which is basically going to be through the binary SRVCTL or through the particular package DBMS service, and that service is basically going to be spread across different set of nodes or different cardinality of the nodes. And this particular segregation is actually going to make us get our systems in terms of load balancing and high availability configuration. So this is something which in terms of the previous versions actually is done by the help of creating the services in terms of preferred and available. And in case we are going to be from 11.2 onwards, we can also have another configuration with the help of something called server pools, which is actually going to be configured in terms of the configuration of singleton and uniform. But if we have to summarize services basically are going to be the logical gateways in order to actually connect to the database. That's basically what is the meaning of services actually is going to be all about. So this is really you can say the main part of service configuration is actually going to be, right, that services basically are the logical gateway through which the sessions actually can discover the database, and they can basically work inside the database. And when we talk about the load balancing and high availability, it is basically due to services that we are actually going to be getting these two features basically available to us. Without the services, it is going to be very hard to implement the configuration of service configuration of load balancing or high availability in any ways. Now, services definitely, like I said, is basically going to be a part of your configuration. And what exactly services do, even though your system can be a RAC system, services provide the view or the illusion to the particular users that they are connecting to a single system, or they are basically connecting to a single instance, even though there can be more than one database instances running in the particular environment. And basically for each service there is going to be a profile created, and that profile is going to be having the information about how that service is linked to your database, it's linked to your instance, and so forth. So this is basically what is actually the configuration of services is going to be all about, that services actually are going to be required to configure the load balancing and high availability in the environment. Now, when we talk about the Oracle database connectivity, it is going to be of paramount importance to talk about something called Oracle call interface. Oracle call interface is basically going to be an interface which is made in terms of C, and this is used by pretty much all the tools which we actually have in the Oracle database environment. So whether it is SQL Star Plus, REST, SQL Loader, everything, it is actually going to be using this Oracle C interface or the native C interface, and this is basically going to be the foundation which is used by other set of things as well, for example the Oracle Net or JDBC or C++ and so forth. And this is something which is going to be required in terms of TAF. So we're going to see TAF actually just in a minute, but this is Oracle's call interface, or OCI, is of the main reason that the TAF actually works in terms of our systems. So when we talk about the particular failover, what exactly the failover basically means, especially at the time of the connection. So this is basically what is going to be happening. The failover is basically going to be the property of the session, and the basic purpose of the failover actually is to get the session failed over to an existing or to a surviving instance which is basically able to support the session which is previously failed. So the failover is something which is by default available to us in terms of the Oracle Net Services environment, and that is basically because this is something which is implemented implicitly within the Oracle Services configuration. Obviously you can still control it, you can still explicitly mention whether for your sessions it is going to be there or not. You can mention that whether the particular TNS names.ora is going to contain the parameter failover equal to on or failover equal to yes, and obviously this can be a part of the Oracle RAC system as well. And if you are using the Oracle RAC, obviously it is going to be working not on the public nodes, but it is actually going to be working onto the VIPs, which are basically going to be there in terms of the Oracle RAC environment. Now when we talk about this failover, what exactly or how exactly it basically works, that is very, very important to understand. So first, basically an example. So you can see that we are actually having the configuration given for failover equal to true, and obviously we have two hosts, host 1 and host 2, which is basically going to provide us this configuration. And here it is an example of a rack system where we have multiple VIPs which are actually going to support this particular configuration of failover for us. So obviously when we talk about failover, that means our configuration is basically going to be served by these two particular VIPs, and within these two VIPs, one of them is actually going to be serving for us in terms of the failover part. Now what exactly the failover is going to do when we have the actual requirement? This is basically what is actually going to be happening in terms of a failover configuration. So when we have a failover happening, basically the session is actually going to be connected. So this is an example of the particular failover requirement where a node is actually going to be down. And you can see basically that the client happen if the particular node is actually going to be down. Now this is basically going to be the question, because the particular VIP which we have running on the node is actually a cluster resource. The VIP is going to be actually relocated by the available node onto the by the cluster aware onto the available node or onto the second node. Now obviously this means the VIP is now moved over to the second node. Now the VIP is moved to the second node. That does not mean the VIP is going to be actually running on the same network card also. This is very, very important. VIPs are basically going to be the public IPs, it's going to be the IPs which are going to run on the same public subnet. Now the VIPs, that means, are discoverable by the clients, and obviously because they are a part of the network, that means they are basically going to share the configuration of the network card. So every network card is basically going to be having the MAC address, and that particular network card's MAC address is basically going to be plumbed over to the VIP address, and that information is basically going to be shared with the client, and it is actually going to be used by the client as well in terms of making up the connection. So when the particular VIP1 is actually moved to the node number 2, this actually will change not only just the host for the particular VIP, it is also going to change the MAC address of the particular VIP as well. Now this is essentially going to be a trouble, because now if the client is going to try to reconnect to the same particular VIP on the second node, it would also need that it will find the same particular MAC address as well, which is not possible. So the particular VIP2 is supposedly going to be actually giving you the connection on the node 2, and the VIP1 relocation is simply because Oracle wants the database disconnect message to come to you as quickly as possible. So you can see that the client will try to connect to the node number 2 with the VIP1. It gets no acknowledgement, and then the client is going to give the username and password again, and finally it will find the another host name and will actually connect over there, and everything is going to be good. So what is the outcome? The connection is lost, the user session is lost, work is lost, and obviously the user needs to connect explicitly. It is very, very important to understand that in terms of this particular disconnectivity, the user needs to connect actually explicitly. The user connection is going to require, or reconnection is actually going to require, that the user is basically going to give the reconnection request by himself. Now if the instance is going to be down, similar situation, you can see that it is still going to be the particular services which are going to be getting sort of like restarted, and you can see the service 1 is actually moved onto the available node, and obviously the service which was earlier preferred is now going to be something which is running as the service on the other node. So the services are basically going to be the one which will take care of the configuration in terms of the instance being down. So what will be the impact of that? Obviously the impact is going to be that the client is still going to give the username and password, still get the error, and will try actually connect to the second particular node. Now obviously in terms of this configuration as well, we are going to find out that the particular service is actually going to make the impact on the system. The user's connection is gone, the session is gone, the work is lost, and obviously the client is going to receive the error, and the client is actually going to require to reconnect explicitly. Very, very important. Aura file implicitly by itself. And basically the TAF is actually going to be available in terms of two modes, in terms of basic and in terms of pre-connect, and also in the types of session and select, which basically means that in the case of TAF, we actually can have the session being failed over, we can also have the select being failed over, but not the DMLs. That is not actually going to be allowed. So that is not actually supported. Basically that's what the meaning of this particular term is going to be. Now in terms of the TAF, what exactly is going to be the scenario? The TAF is first of all going to require that we are going to be having the configuration of the TAF mentioned in the SRVCTL. Now when actually we are having a TAF configuration set, the TAF is basically going to be having certain number of retries and timeouts actually mentioned in it, and that is basically going to be remaking the client look for the connection for that many number of times in the database environment. Now in terms of the TAF setting, which is going to be done on the service side, obviously it is basically going to overwrite any setting which you're going to do explicitly in terms of tnsnames.ora, but it is going to be something which you can do on either side. You can make the TAF settings in the tnsnames.ora, or you can even do the TAF settings in terms of the SRVCTL. Usually it is better to do the TAF configuration in the SRVCTL, because SRVCTL is a cluster binary, and obviously it is going to update the cluster profile, the OCR and all very, very correctly, instead of just having the entry in the TNS names. So what does TAF does in the same scenario of the node crash? Now, same scenario, we are having the username password given connected to the VIP1. Of course, we have the connection and the node number 1 is gone. Now comes the issue that we are basically going to be told that okay, the VIP1 is not available and we should actually try to go for the VIP2. Now instead of we actually going for the particular reconnection by ourselves, it is going to be TAF, which is basically going to say, actually not say, but actually going to behave like that, okay, since you have gotten a disconnectivity, let me try to actually handle this particular exception for you. And how it is going to be doing that? Basically it is going to actually attempt to do the retry of reading this particular tnsnames.ora file by itself. So now the client is actually going to be reading the tnsname.ora file by itself, and it is actually going to be now giving the connection request to the node number 2, and obviously it is now going to be connected. So basically the impact is the user session is still gone, the work is still gone, connectivity error is still going to be there, but the user is going to be reconnected implicitly, and the user does not need to be actually connected by giving the username and password again and again. This is basically what the purpose of the TAF is. So it is basically transparent application failover. That means the application will actually get the failover happened, but without really actually doing anything about it. So obviously this is basically what the TAF is actually going to be doing for us. Now we have two methods for the TAF available. One is a TAF basic and a TAF pre-connect, and we already mentioned that what exactly is TAF basic. The TAF pre-connect is basically where we are basically going to configure an individual service or extra service onto another node, which is going to become active and is actually going to make this particular failover happen to that particular node once the primary service running on the primary node is actually going to be down. Now how can you configure the TAF on the client side? Well, you can actually configure the TAF on the client side simply by putting all the configurations of the TAF in terms of your client side tnsnames.ora, and obviously if you want to configure it on the server side, which is actually going to be a better thing to do, then you can do it actually with the servicectl command. Now you can actually see that we basically can have the TAF configuration done on the server side as well. And if we are going to be doing everything on the server side, which means the servicectl command is basically going to be having everything included inside it, that means we would not really need actually anything in the tnsnames.ora. tnsnames.ora can be very plain Jane compared to the TAF configuration done in terms of the tnsnames.ora. But is TAF is actually enough? Now the answer of that is actually not really, because TAF basically is based upon timeout. That means there are going to be multiple different tries which are going to be done by the session before the session is actually going to understand that the particular database or the instance it wants to actually connect to is not available. And that is basically going to be a bad factor, and the reason for that obviously is that if the client is going to do a wait basically to get the retries done, it is going to simply delay the particular process of reattempt, or the attempt actually to go to a different node. Now this is the reason that there was something else needed basically in comparison to TAF. So this is an example that TAF is not going to be good, because if a node is going to fail, obviously it will close all the sockets, and the connected sessions, they are basically going to be waiting in terms of the IO. So the sessions which are still processing the results are going to be in a hung state, and once the sessions are going to receive the particular message from the Oracle's interface through either TAF or whatever, that now they have to disconnect, because obviously now the particular client is not able to find the instance, and it is actually being told by the other node that it does not have the same MAC address as was there in terms of the previous session. So this basically means that TAF is actually a timeout based environment, and that is not a very beneficial environment, especially when you're looking for doing the failover in terms of very quick manner or almost right away actually in terms of the environment. And this is something which is going to be taken care by fan. So basically what exactly the fan does, fan basically gives the user something called an application notification. Now the notification given by fan is basically going to be something which is about the user's instance is not running, or maybe the database is not running, or the node is down. So whatever actually is the information method that is basically going to be shared actually by the particular fan to all the subscribers. And who are going to be the subscribers? Basically going to be the client applications, or maybe the clients who are actually willing to connect to a specific service or to a specific node and so forth. And because this information is sent by the cluster node, it will be immediately consumable, and that means the clients do not actually need to wait for a certain timeout to get the confirmation that okay, a node is really down or a service is really down. So obviously it is basically going to be better because the fan events are pushed actually to the applications, and obviously with the fan events we actually can do the load balancing as well very efficiently, simply because we actually will have a much better way to actually transfer the information about the service or the node or the instance. Now that means TAF is actually timeout based, fan is basically event based, and that is the main difference actually in terms of the TAF and fan going to be. Now if you're using all of these particular things or any of these particular things, for example the JDBC connection pool, or you're using the ODP connection pool and so forth, so that means all of these particular things are actually going to make the fan properties available to you natively, and obviously this is something which is going to be helping out immensely in terms of your environment. So basically what is going to be there in terms of fan, so you can use fan without really doing any kind of programming changes. You can use the programming as well with the particular JDBC and Oracle RAC APIs, fan APIs. And you can also create something called callouts in terms of a database environment, basically to react upon a particular fan event whenever it is actually going to occur. So basically to mention this particular event, there are different processes available. So we have ONS, which is basically the notification server. If you're using OCI, if you're using JDBC or Java, any such APIs, Oracle will be using the ONS from the cluster nodes actually to send the information to the clients. And the advanced queue, if you're not actually using ONS or ONS OCI or Java or JDBC, then the other option is going to be the AQ. And if you want to send the information to the enterprise manager, there is going to be another daemon called EMD, which is going to be doing the task for you. Now in case you want to install this RAC fan API for any purpose, or for example you want to actually do the configuration or want to get the configuration or so forth, that you can actually do by basically downloading the particular fan API from the link which I've mentioned, and you can actually start from there. Now in terms of the particular fan, we actually have an implementation called fast connection failover. The fast connection failover is basically going to be an implementation which is done on the connection pool environment, and this is basically going to be done automatically and without really actually any delays whatsoever. Now the FCF is basically going to be available to you in terms of JDBC or ODP.NET clients, and obviously it is going to be also available to you in terms of local instance or in terms of the remote instance. Now in terms of the FCF to be enabled and to be working, we basically are going to require that there is going to be the load balancing advisory which must be actually available to us, or which must be actually working for us in terms of the system. Now, which one is going to be better, TAF, FAN, or fast connection failover? Well, as I said, FAN is not timeout based, TAF is. So in case you are looking for a kind of communication or the kind of mechanism which really does not wait for any reason whatsoever, then the purpose can be solved by FAN. Obviously, if you're using FAN, that means you basically will be able to achieve the application failover mechanism, and you can actually use along with the FAN, if a connection pooled, then you basically can use the fast connection failover as well. A fast connection failover is basically for the thin clients, like the connections which come and go very quickly. For those particular things, you're basically going to be using the fast connection failover. Now, this is sort of like a logical break in terms of the webinar, and the question basically is that is it still going to be enough? And the answer is no, because even when everything is going fine, there can be situations where even these particular technologies, TAF and FAN, and maybe the fast connection failover, they do not really work very well. And the reason being basically is that in terms of the database environments, it could be possible the client is giving a request to do something to the database. The database has done the work, but the client never got the response from the database, and this is something which can create quite a big trouble, because the client, for example, if I've paid some money to do some task or maybe to purchase something, now that money is already going to be debited from the client's bank account, but because he has not gotten the message about that particular information, this is now going to be a trouble for the client, because the client is possibly going to now doing a retry, which might end up into the payment done twice, and obviously possibly the access is not actually going to be granted still. So to overcome this situation, Oracle has basically two options. One is in terms of 12c onwards, one is which is called transaction guard, and the second one which is called application continuity. Transaction guard is a protocol and obviously an API which basically is going to protect the transactions in terms of this way, that if a transaction is actually completed, it is going to check that whether that particular completed transaction is having what status. So this is something which is going to be important, because by this only we are actually able to see that what was the reason the particular problem did occur in the first place. And obviously the transaction guard is basically going to be working out for you out of the box. Obviously you can configure it in terms of your environment, but for a DBA it is going to be a very simple thing to do, or very simple actually thing to basically configure. Then we have another thing called application continuity, which is again going to be a particular requirement. Basically, in case you can actually see that there are a lot of issues, or maybe you have connected and your particular instance got disconnected. Now in that scenario, you are basically going to be having this problem of getting the error messages and then trying to reconnect and then eventually getting connected. What does the application continuity do? It basically masks those error messages which otherwise would have basically come a lot in your session and would have made the application using experience not a very good thing. And that's basically going to be the trouble which the application continuity is actually going to solve, because application continuity is basically going to present a sort of like seamless behavior to the client, where he cannot really see the error messages, and eventually in the background you can actually retry your particular transaction or work depending upon the requirement. So transaction guard, how that is actually works? Well, the magic in the transaction guard basically is in terms of something called logical transaction ID, which is basically going to be an ID that is assigned to the transaction by the clusterware, and this particular transaction ID is going to be checked by the system next time. So this transaction ID, if it is same for a transaction, they will already have the transaction's status information stored in the clusterware, and because this information is stored, they can actually check, system can actually check very easily that what was the last status of the particular transaction. Was it completed, was it not completed, or if it was completed, was it a commit or was it a rollback. Now obviously that means the transaction guard does not really need any additional setting. We can actually make the transaction guard work actually even in the case of independent manner. We basically do not really need application continuity or any such things, basically a part of transaction guard. So obviously transaction guard is basically going to maintain the session state. It is going to check for the request, which could be any kind of request possibly coming in the system, and then it is going to be the outcome which is going to be taken care by the logical transaction ID, and also it is going to be the functions which are basically going to be working in the background, and there are going to be functions which are basically going to be mutable. So what exactly those functions are going to do and how to actually maintain them will also come under the part of this particular transaction guard. So logical transaction ID is basically going to be the transaction ID that is created with the at most once execution, and this is going to be something which is going to be the main thing in terms of the transaction guard. So in case you want to use this particular thing in your environments, if you're a developer, you basically can use this particular get transaction ID API, and you can actually use the transaction ID created actually by yourself to basically play around with it in your system. Now these are some of the drivers basically available in terms of the configuration, and obviously depending upon the requirement you actually will be able to use transaction guard. Now this is transaction guard sort of like in action. So basically a client is going to create a connection, and the client is basically going to start a transaction, and once the client is actually going to start a transaction, the client is actually going to be assigned, the transaction is actually going to be assigned a logical transaction ID. Now once the particular logical transaction ID is going to be there, whatever the status of the transaction is, that is going to be stored in the system, and in case the information is not able to go back to the client, now when the client is going to be coming in and retrying, the client is going to be assigned a new session, but we can actually call the old transaction ID by the programming interface, and with that we can actually compare whether the particular transaction earlier was a committed transaction or not. If it is not a committed transaction, obviously you have to reattempt it or retry it, but if it was a committed transaction, you basically will get the outcome reliably available to you that okay, it is already done, you don't really need to do it again and again. So this is basically what the transaction guard is actually going to be doing, and obviously the information about the transactions is basically in a structure called LTX ID underscore trans, which is basically going to retain the old transactions for 24 hours. The client is just going to need to know the transaction ID, logical transaction ID, which is going to be shared by the client and obviously by the database. And the transaction guard is basically going to check that the transaction IDs are unique, and obviously that is going to be the main building factor of the logical transaction ID is actually going to be all about. Now this is basically going to be a pseudo workflow that in case an error comes, for example a fan down error comes, the fan is basically going to abort the dead session. If the attribute is a recoverable attribute for the particular transaction, the last transaction ID is going to be checked, the new session is going to be created, and now using the get logical transaction ID procedure, basically the particular comparison is going to be done. If the last commit was actually a commit, that means obviously there is no use to do anything, but we can simply show the result. But if it was not actually, then we basically are going to be checking other things out. So this is not actually a code, and obviously I would not ask you to basically look into that as the perfection, but obviously this should give an idea that how we can basically work with the transition guard in our systems. Okay, so now once the transition guard is over, this is basically some of the things where the particular transition guard is supported or not. So you can see that in terms of the autonomous transactions and active data guard and other such things, currently it is not really supporting. Of course, you need to keep on looking at different versions and the new versions coming up where things may actually change, and obviously many things which are not supported or possibly not available now, they are possibly going to be available in the next versions which are going to come. So obviously once the particular transition guard is completed, we actually can use it by a number of ways in terms of the system. So we can use it by the system through the particular package. Obviously we have to execute the privilege on this particular package to the users. We need to find out a couple of parameters and their values we need to set. For example, commit outcome to be true, failover type to be transaction, and for how long we basically want the transaction to be actually present, and that's basically going to be the retention timeout. Now this is how the service configuration for the particular transaction guard is actually going to be required. All what you have to do is basically set in the service the commit outcome equal to true and the retention parameter, and it's going to be the retention value for that. Obviously you can do it in terms of any particular environment, whether it's going to be a single instance or it's going to be a RAC environment. Now the application continuity is basically a feature which is actually going to be using the transition guard. Now the idea basically of application continuity, as I said already, is that application continuity is basically going to be making the impression to the user that there is no error anywhere happening in the system, and whatever error which we are actually going to be having in the system is basically happening internally. It is not going to be really impacting the users, and that is basically going to be the functionality of application continuity is. Of course, it does not stop here. The application continuity is basically going to connect your particular previous work. It is going to connect you to another available instance. It possibly will replay the transaction of yours using the transaction guard implicitly. So basically application continuity is able to use transaction guard but not the other way around. And application continuity to work, we basically need the particular transaction guard to be present also, which is again not a requirement for transaction guard. Transaction guard can work on its own in terms of the system. So basically what does the application continuity do? It's going to be available first of all for these particular set of things. It's available for Java clients, for database servers. It's basically going to require transaction guard actually to be working, and this is basically going to be the requirements for the application continuity. Now you can see that application continuity is basically going to check these things. It's going to check that you had a normal phase of running, you're going to make a connection, you're basically going to work and build up the objects and whatnot, and then you will be having a crash. In that case, you'll be actually required to do first of all a reconnect. So obviously this reconnection request is going to be created by the application continuity. It's basically going to find out that which database is appropriate for the particular system, and obviously once it has identified all of that, now the replay is actually going to be started. And of course with the replay, the user is able to check and confirm the data which was earlier actually not used by the by the system. Obviously now the exception is going to be raised that the client is having some trouble in terms of the connection, and finally the replay is going to be actually attempting the connection and doing the work in the background on that particular error's behalf. If again the error comes, obviously the replay is going to be unsuccessful, which is going to result the error given to the client again. Now, this is basically going to be the end for the presentation for us, but what is actually, it is in terms of takeaway going to be the failover properties in the system is by default there, so you should be using TAF at least minimally explicitly to handle the connection request failures or instance failures actually in the system. Fan obviously is going to be good, and using fan you would be able to manage and find out the particular ways to actually get the notification to your clients much easier. And fan is basically going to be a much efficient mechanism as compared to TAF. Now, the transaction guard and application continuity, they are basically going to be the flag bearers actually about the high availability in the versions from 12c and above, because they actually provide the functionality which possibly will be needed in terms of practical world a lot. Like you are going to do the attempt to do the particular page refresh of your transaction, and once you have done that particular page refresh, the session state is actually gone, and obviously that is going to be the trouble for your transaction, and that's the reason you are told that don't do a page refresh actually when you're doing or when you are actually underlying in a transaction. And that's basically going to be taken care with the help of transaction guard and application continuity, that the correct sessions information and the replay of the transaction is going to be attempted by the system automatically. And this is going to be the main functionality of the application continuity and transaction guard is actually going to be. So that brings us to the end of this particular webinar session. Of course, if you have any questions, if you have any doubts in this particular presentation, do let us know in the comment section, and we'll try our best to actually answer it. And of course, we are having a lot of other webinars and webinar sessions and quick tip sessions on the channel, which you can also check out and give feedback about. As always, I'll see you in another tutorial or maybe another video very soon. Till then, thanks a lot for listening, and goodbye.